Alright, this LeetCode question is called Symmetric Tree. It says given a binary tree, check whether it is a mirror of itself, meaning is it symmetric around its center. For example, this binary tree is symmetric. So we have 1 and then 2 matches 2, the 3 on this side matches the 3 on this side, and the inner 4s match each other, so this is symmetric. But this one is not, because even though these 2's match each other, this 3 should be on this side to match this one. All right, and we're going to solve this recursively. All right, this question lends itself really well to recursion, so that's the method we'll use. If we look, this can be split into a left half and a right half. And what we actually have are two triangles. But we don't really need to consider the top of this much in our evaluation of whether these are mirror images of each other, because it's only one node. Of course, that one node is a mirror image of itself. So we're really just going to consider these two. All right, so how would that actually work with recursion? What we'll do is we'll pass in this, and we'll check to see if they're equal. If they are, we'll pass in the left child of this and the right child of this, and we check to see if those are equal. Then we pass in the left child of this and the right child of this, see if they're equal. Right child of this, left child of this, see if they're equal. Then because of recursion, we naturally bounce back up to this level. And at that point, the right child of this gets passed in, and the left child of this, the left child of this, and the right child of this, the right child of this, and the left child of this. And then we're done. If all of those are equal, then this is symmetrical. All right, what LeetCode has given us is a function called isSymmetric, which accepts a root, and the root is the entire binary tree. So the first thing we can do is say if the root is null, then we'll return true. This just means that it is symmetric. Next, we'll need a helper function. And what this helper function is going to do is compare the left and right nodes of the tree that is passed and determine if it's symmetric. And remember that it's going to do this recursively. So we'll name it isMirror, and it'll accept two trees. Okay, let's jump back up here and we'll pass it the trees. We'll say return isMirror. What would the two trees be? They would be the tree starting with this and the tree starting with this. So that would be root. Remember, root is the first node in this tree. So root.left, which would give us the number 2 on the left, and root.right, which would give us the number 2 on the right. All right, so what does isMirror have to check? It has to check, first of all, if either node passed in is null. If either node passed in is null, we can just do a comparison right there of whether they're both null, in which case it'll return true, or whether only one of them is null, in which case it'll return false, because obviously the two are not the same. So that check will say if tree 1 is null, or if tree 2 is null, we'll just check the equality of those. So return tree 1 is equal to tree 2. All right. In our diagram to the left, neither of those is null. They're both trees starting with the number 2. So now we have to check the value of each. So we'll say if tree1.val doesn't equal tree2.val, then we'll return false because they're not equal. But if we've gotten past those two if statements, it means everything is equal so far. So now we have to make the recursive call to check these trees' children. That would look like this. Return is mirror, so I'm calling myself. And what am I passing in? I'm going to pass in tree1's left child, so tree1.left, and I'll compare that to the right child of tree2, so tree2.right. That would be these two, tree1.left and tree1.right. But notice we haven't taken into account tree1.right and tree2.left yet. We'll add that. So we'll say is mirror tree1.right and tree2.left. That would be these. All right, that's the end of the code, but I'll walk you through exactly what's going to happen from this point forward. Let me undo those two. So tree1.left has been passed in, that's the number 3. Tree2.right has been passed in, that's also the number 3. So on line 21, it's going to check to see if either of those is null. They're not, so it goes to line 25. Are the values of those two the same? Yes, they are. So now we go to line 29. The beginning of line 29 says again to pass in tree1.left, which would be here, and tree2.right, which will be here. Line 21 asks if either of those is null. Yes, they're both null. So that would return true because they're equal. What happens now is it jumps back to the number 3 and goes to the second half of the statement on line 29. It says pass in tree1.right, tree1.right is this, and tree2.left, which is this. So on line 21, it's asking if tree1 is null or tree2 is null. They're both null, so that's going to return true. What happens now is that the recursive calls jump back up to this level. So now we're going to take care of the right half of line 29. It says what's passed in is tree1.right, which is this, and tree2.left, which is this. Now we're on line 21. Is either of those null? No. Line 25, are the values equal? Yes. So then we pass in the left side again of tree1 and the right side of tree2. So we're back on line 21. Is either of those null? Yes, they're both null, so we return true. So then it jumps back up to the number 4, and it says pass in tree1.right, which is this, and tree2.left, which is that. It checks if they're equal. Yes, they are. So it returns true, meaning this entire binary tree is symmetrical. All right, let's run the code, see how we did. Looks good. Let's submit. All right, so our solution was faster than about 89% of other JavaScript submissions. As usual, the code and written explanation are linked down below. If you liked the video, give it a like and subscribe to the channel. It helps out a lot. See you next time.